Dear students, now let us see what will be the output of a first order system if it is subjected to a unit impulse function. Okay, again start with the system response, that is the output for first order system. Is given by, that is C of S is equals to Rs multiply 1 by St plus 1. Okay, if unit impulse input is there, then RT, that is time domain RT, will be equals to delta T. This implies that your Rs will be equal to 1. Okay, so let's take the final response. Then in this way, this implies that C of S becomes 1 by St plus 1, or take T as common. So it becomes 1 by T multiply 1 by S plus 1 by T. Taking Laplace inverse of both sides, we will get C of T will be equal to Laplace inverse of C of S, and this will be equal to Laplace inverse of 1 by T multiply 1 divided by S plus 1 by T. And if we solve this, then we will get, that is Ct will be equal to 1 by T e raised to power minus T by T. Okay, so in this case your response Ct, because we have here applied the unit impulse input, so the response will be like this, that is, suppose we take the axis. Okay, so if we put different values of t in this function starting from 0, then your Ct at t is equals to 0, its value will be, that is, at t is equals to 0, Ct will be equals to 1 by t. Let us suppose this is your 1 by t. Let's this is your 1 by t. Okay, then as soon as the t will be increasing, the Ct will decrease. Okay, and at t is equals to infinity, Ct goes down to 0. So it exponentially decreasing like this. Okay, so this is your time. Let us suppose this is your t, this is 2t, this is 3t, and this is 4t. Okay, then after that 4t, it will achieve its steady state response. Okay, now if we look at different responses of a first order system, then we find that here these are the inputs which we have studied. Okay, and if we draw write their expressions, that is, this is your unit ramp input, unit ramp in S domain is denoted by this one, and if it is unit step input, then its Laplace transform is 1 by S, and if it is unit impulse input, then its Laplace transform is 1. Then time response expression which we have studied was Ct is equals to t minus t plus t e raised to power minus t by t. In this case, the time response was 1 minus e raised to power minus t by t, and in this case the response was 1 by t e raised to power minus t by t. If you look at the relation, then we find that if we differentiate the time, the response received from unit ramp input, then we will get the response of unit step input. Similarly, if we differentiate this equation, then we will get this equation. So, differentiating a particular response will give the response of unit step, or unit steps differentiation will give you the response for unit ramp. Similarly, if we integrate this function, then we will get the response which was for unit step input, and if we integrate this function, then we will get the response received at the time of unit ramp input. So if we differentiate, we have to move this side, and if we integrate, then we have to move this side. Okay, just this table is important, that if a student or if a person is having the unit ramp response of a system, then you can easily calculate its step response and its impulse response. Similarly, if an impulse response is provided with the system, then you can easily calculate its unit step response and unit ramp response. Okay.